And then I forgot to mention this before, but if you're interested in getting involved with ASHRAE, whether it be any chapter or any chair position or whatnot, and you would like to volunteer, I know ASHRAE has a contact us page. If you don't have anybody's direct info, we took all the emails off there because we were getting spam. So you can't contact us directly, but we do check that contact us page pretty frequently. But without further ado, we have Amanda Bogner today, who is a ASHRAE DL. Amanda Bogner is passionate about architectural sustainability. She lives and breathes energy savings and provides clients with meaningful energy modeling analysis. She has significant knowledge of building systems and how those systems affect facilities' overall performance. Her company's tagline reflects her deep passion, become more powerless. Sometimes Amanda whispers that she's trying to convert the heat. Amanda is president of Energy Studio and is a registered mechanical engineer and is a certified ASHRAE building energy modeling professional with 20 years of project experience. And she has dedicated her career to providing meaningful energy modeling and analysis to owners and design teams. Pass on over.
Hi, Amanda.
All right, thank you. I guess I have to share my favorite holiday movie as well. I didn't hear anyone mention The Holiday with Cameron Diaz and Jude Law from eons ago, a rom-com. So if you're looking for a new one to watch, it's mostly friendly, family friendly, appropriate. It's a pretty good one. So, all right, we'll get into today's session. Thank you very much for inviting me to be a distinguished lecturer for your group this year. I appreciate it. We're going to talk about leveraging the value of your energy model, and it looks like coming up in January, you're going to have a panel on making the engineering case for energy modeling and including that. So this will be a really good primer and springboard for you to head into that panel. I'm happy to take questions throughout the presentation. If you do have questions, I've enlisted Dylan to help me manage the chat online. So feel free to enter a question there and or interrupt me, and I'm happy to answer questions along the way. So, all right, with that, we'll get going. So generally, this presentation is going to explore how early phase energy modeling improves design outcomes and energy performance. It guides the use of we'll talk about an early phase energy modeling checklist that you can use to really communicate really well with your energy modeler that will just help promote better outcomes ultimately. We'll also demonstrate how to apply insights to enhance aesthetic and energy efficiency. And we'll look at strategies for effectively communicating energy goals and performance results to diverse stakeholders. All right, with that, I won't bore you with more of a bio, but based in Omaha, Nebraska, I think we're actually having a colder day than you are. I have never looked at Boise, Idaho weather before, but I pulled it up today to see what you were dealing with. And it's very cold in Omaha. We're around hovering around 20 degrees. So I would much rather be where you are right now. Sitting closer to 30 degrees sounds good. All right, our presentation overview, we're going to take a systematic approach to talking about how to leverage an energy model. We're going to start with what is an energy model and kind of unpack that. We're going to move through how it can be leveraged during a design. With that, we're going to talk about what a potential workflow could look like. And then we're going to end with how models end up paying for themselves and highlight a little bit about Inflation Reduction Act and how the tax deduction from Section 179D collaborates with an energy model, if you will. All right, this whole presentation is software agnostic. So I saw that on the invite for this presentation, you have a graphic that shows all the different energy modeling software. What we're going to talk about today is kind of agnostic to the software choices that you're making. Certainly workflow choices, or I'll say details, kind of is affected by the software that you choose, but that's kind of beyond the presentation. But we can talk about that in the Q&A section. All right. So let's go going and talk a little bit about what an energy model is. But before we do that, let's talk a little bit about why energy efficiency is so important. So energy efficiency is no longer just an option, but it's becoming a necessity in contemporary building design. And this is kind of a four-pronged. So the environmental impact that buildings have is fairly significant. When we look at global energy consumption, buildings make up about 39 to 40% of the total global energy consumption in the world. And so designing energy efficient buildings can drastically reduce that environmental footprint. Over time, energy efficient buildings lead to substantial cost savings on utility bills, benefiting both owners and occupants. And then many regions around the world have established energy codes and standards that buildings must adhere to. So energy efficient design ensures compliance with these regulations. And the efficient buildings often result in better indoor air quality, temperature regulation, and overall occupant comfort. All right, so now we can start to answer the question about what an energy model is. So this is a virtual simulation of a building that predicts its energy consumption patterns based on a set of defined parameters. It considers various elements such as building materials, HVAC systems, lighting systems, occupancy patterns, and local climate conditions. So you'll see this graph that I have on this slide later in the presentation. We'll kind of unpack the details of it, but kind of wanted to give an image of, a real life building, so a photograph of a building, how it might look in an energy model. In this case, this was eQuest software a long time ago. And then how that performance might be translated to kind of a graphical or a visual representation. So we'll talk a little bit more about that specific case study in a little bit. All right, so let's talk about the benefits of using energy models, and then I'm sure your panel next month will kind of expand on this. When we're looking at this, we really are looking to improve energy efficiency. That's the bottom line of why energy models are usually engaged by design teams. And this is really done because it helps inform decisions. Energy models allow architects and engineers to test a variety of design alternatives and select the most energy efficient option. It provides a holistic view. So beyond individual components, energy modeling provides an integrated view of how all the building systems interact together. And it helps us reveal synergies and conflicts. And we also can do a little bit of predictive analysis. So rather than reactive adjustments post-construction, using an energy model can help in predicting performance and making proactive design choices. We also look at cost savings over building life cycle. Obviously, that's very important for our owners and operators. And so using an energy model, we can help reduce operational costs. So again, kind of going back to that, analyzing a variety of alternatives, we can also understand which of those alternatives lead to decreased energy consumption or decreased demand, electric demand or energy demand, and that often will lead to operational cost savings. We also find that using energy models has a link to building functionality and occupant comfort. So energy models ensure that buildings maintain desired temperature levels and ensure comfort for occupants. We look at indoor air quality and sort of that nexus between providing proper ventilation with balancing that with the energy consumption associated with conditioning that ventilation air. And then, one of the things that we've seen really a big uptake in energy modeling is meeting regulatory or environmental requirements. So certainly 20 years ago, most design teams weren't using energy models on the regular, but with the advent of LEED and other sustainability certifications, energy modeling became an invaluable tool to validate performance and document performance for like your LEED certification. But then even within the last 5 years, we've seen really a ramp up of how stringent energy codes are becoming. And I always look up what your local energy code is before I give one of these presentations. And I see that Idaho has adopted IECC 2018. That's also the same energy code that we're under in Nebraska. And it's a fairly rigorous code. Energy models help design teams understand how to comply with those codes and what our different pathways and options are. Ultimately, we're all trying to reduce a carbon footprint, Buildings play a pivotal role in global carbon emissions. Optimized designs can significantly reduce a building's carbon footprint and contribute to larger environmental goals. All right, let's move on here to talk a little bit about high level, what the work looks like, and then we can talk a bit about how we might leverage these. So energy modeling requires a systematic and organized step-by-step process. Attention to detail and organization of data is kind of where we start on the left side of this funnel. So when we're starting a project, we're looking at collecting, whatever information is available from the architecture team. That might be what's the geometry or massing looking like, what type of materials are they thinking about for the envelope. We're also, looking to get details about the HVAC system, understanding equipment specifications, efficiencies, even thermal zoning strategies. They all play into how a building ultimately will perform. We're gathering information about lighting systems, not just fixture counts and, lamp wattages. We're also looking for understanding on controls, what type of daylight strategies might be available, and evaluating those energy savings potential. But really, that's not much different than a load calc, right? Where an energy model changes it up is we apply operational schedules. And we're not just looking at your design days, at end of summer and in the dead of winter. We're looking at how the building performs at every hour over the course of a year. And so understanding how that building is going to operate, how occupants are going to interface with the building is a really critical element of that data collection piece. Then we move into this evaluation phase. So, which really is kind of a three-pronged, three circles here that intersect, but it's also iterative. So I don't have that described on this slide very well graphically, but very much we move from a simulation and analysis and optimization, and then we might do that work again. And again, sometimes multiple times. So in that simulation piece, we're taking all that collected data and we're putting it into our modeling software, whatever software that might be. Making sure that from a data quality standpoint, things line up and that we know where those, if assumptions need to be made, what are those assumptions? How are they appropriate for the building type at hand? And then we go through an analysis process. It's often not just a click of a button. There are many times where once you get your results, becomes a head scratcher of why is my building showing me that thing right now? And that's really kind of where the analysis piece digs in, and an energy modeling team would dig into those results to understand, was there an error in the data entry? Is this performance expected? Does that align with what we would likely see in the field? And then we go through the process iteratively to optimize the design. And so this can look at, like I said, testing alternative materials, system types, all those things. We would typically adjust things on an individual basis and then start to group things together in a bundle. We call them energy conservation measures, or ECMs. So you'll hear me refer to that acronym throughout this presentation. But we're really trying to come up with viable bundles of ECMs that could work with the project budget and work with ultimately the building owner and his facility and their facilities team, to make sure that this isn't just a building on paper that demonstrates good performance, that it ultimately demonstrates good performance once it's in operation. And this then moves on to the reporting phase. And so really trying to marry up our findings from the evaluation phase to actionable results that the design team and stakeholders can take to the next level. All right, let's move on here now to talking a little bit about how we leverage an energy model. Okay, so you might be surprised to hear me say that not every building needs an energy model. While there are many questions that an energy model can help answer, which we'll go through shortly, there are buildings where it might not be necessary. For example, a small building can comply with the energy code prescriptively, and an energy conscious decisions have been made throughout design. They probably don't need an energy model. Another misconception is that an energy model will limit a designer's creativity. In reality, we've actually seen energy models do the exact opposite. It puts boundaries, sure, but then an energy model can be used to confirm and defend design choices. So for example, if a design team, mainly an architect, wants to add more glass, kind of, you know, the old adage, we're mechanical engineers are always against all the glass. The energy model can be used to justify that idea by balancing the additional glass with another trade-off. Perhaps it means, you know, a change in the lighting system, or perhaps it means a better efficiency on a chiller or something like that. This then gives the owner line of sight to, okay, if we're making the decision over here, what dial do we need to change over here to make this design work? So it's more about asking the right questions at the right time, which usually means in the design world, asking questions as early as possible. All right, so the old adage of begin with the end in mind is especially meaningful in energy modeling. So energy models are most effective when they are developed with a clear vision of the end goals. This ensures that the energy modeling process is purposeful and aligned with project outcomes. Energy models can be used to develop a robust energy strategy and achieve energy goals like meeting energy usage index targets or EUI targets, and reducing operational carbon. We can use models to meet many goals beyond just LEED credits, including tax deduction documentation, applying for utility incentives, and demonstrating co-compliance, as I mentioned earlier. By leveraging an energy model early in design, when a stringent energy code is applicable, allows an owner and project team to have line of sight to how the design compares to the code early on, which avoids costly redesigns and ensures regulatory approvals once we go in for permit. Finally, in the measurement and verification phase, a design case energy model sets the baseline for post-construction M&V efforts. So it really helps then the owner know, are we inbound or out of bound of reasonable operations when we look kind of at our total energy bill. It's not going to be absolutely perfect. The energy model's never a one-to-one comparison to real life, but it kind of gives us an order of magnitude that we can work from to try to troubleshoot operational issues. All right. But along the way, we often see design teams throw in other things to what the energy model needs to do. So occasionally we'll get, pinged by architecture teams that they are a 2030 challenge signatory and they need help reporting. Well, thankfully we have an energy model to provide that information. We can also gather knowledge about our building's peak electric demand. So if there's any coordination or discussion with the local utility about what a peak electric demand will be for the new building, the energy model can inform that. There are so many uses for energy models, but when we're setting scope of work and when we're looking at, I'll say the field of possibility, we really need to understand at the beginning or the outset of a project what the energy model might need to be used for, because it affects the level of detail that goes into that model. All right, so I mentioned that energy models can be used to answer a lot of questions. It's not just a technical tool, but a decision-making resource. Questions can cover a wide range of areas from energy efficiency, what energy efficiency we need on a particular piece of equipment, to is my building compliant with the energy code? This is a small sample of the most common questions we hear on projects. At a high level, energy models provide indicators by estimating energy consumption, carbon footprint, and the financial viability of energy efficiency and renewable energy strategies. And we can get design-specific insights. So energy models evaluate design-specific questions, such as the impact of building orientation or envelope design choices. How much insulation do I need in this wall? We also can look at passive design strategies and HVAC system choices. Finally, energy models address co-compliance by verifying adherence to energy standards, and they can be used to evaluate grid interaction through strategies like demand response and peak load shaving to optimize utility, grid performance, and costs. And I think that that last piece is really something that is becoming absolutely critical to our electric grid. And a lot of design teams, when they're focused on a building, are not necessarily thinking about how does this building impact the wider grid. All right, so let's move into a little bit about what the workflow looks like. All right. The initial phase of the design process is where energy modeling goals are usually first defined and incorporated into a project vision. This step sets the foundation for integrating energy modeling into the entire project life cycle. So let's look at that. All right, and my click's not working. All right. So when we're thinking about this first phase of an RFP and or having a design charrette, we're really after a couple things. We want to establish our energy goals. So establishing clear and measurable energy goals during the RFP or the charrette stages is absolutely critical. So an RFP from an owner might call out specific energy goals. I am curious to know if you're seeing that in your area. But if they're not specified there, then the charrette is the opportunity where the design team has an interaction with the owner to be able to establish what those goals should be. The charrette is a collaborative workshop where stakeholders, all the design team members, as well as the owner and sustainability consultants, come together to discuss project objectives and kind of get on the same page. Including energy models in these early conversations ensures that energy performance goals are realistic and aligned with design priorities. This is often where the scope of energy modeling services begins to be defined. So for example, if the model will focus on envelope design, HVAC systems, or renewable energy integration, that needs to be known at the outset of writing a scope of work for energy modeling. The performance metrics will guide the project, and this clarity helps avoid scope creep and ensures the modeling efforts are targeted. We also find that these stages involves identifying opportunities for passive design strategies, renewable energy systems, and efficient building systems. So decisions made during this phase are often long-lasting. You think of early conceptual design where we're setting a building on a site. Once that decision is made, it's very hard to unwind that one. Energy modeling at this phase provides a roadmap for the design process. It ensures that energy efficiency is prioritized and embedded into the project from the very beginning. All right. We talked a little, I mentioned just now a little bit about energy goal setting, and sometimes owners come with those energy goals already identified. But part of our effort during that early phase is making sure that that energy goal is right-sized for a project. Energy setting is affected by a variety of factors, including, what type of building it is. Certainly a school uses energy differently than a hospital, and so they would have very different energy goals. The climate plays a key role in what is possible at a particular project. Local code stringency certainly influences what kind of our minimum threshold should be. But sometimes I find that project teams kind of focus on that and they're not looking at the opportunities to go beyond code stringency. All right. Looking at hours of operation, certainly 24-hour a day facilities operate very differently or use much energy much differently than buildings that have standard business hours. I'll skip a couple of these. I think they're pretty obvious. But I'll talk a little bit about special spaces. So when buildings have special spaces that are very different than the other uses of the project, that can really start to influence your energy goal. So you have an office building or a university building that also includes a data center or a laboratory, or like a big space like an auditorium that would have a lot of ventilation air. Those very unique space types start to impact what those energy targets could be for the entire building. So really having a clear understanding of that. All right, these factors collectively guide the energy goal setting process, ensuring goals are practical, aligned with project constraints, and tailored to the specific needs of the building. All right, I provide this slide just so that you have some resources, and I'll follow up with Dylan to provide a copy of the presentation that includes my notes. And the different web addresses for all that will be included as well. But these are some resources that can be used to set an energy goal. So typically for existing buildings, we would look at the historical energy use of that building, and that might establish our baseline to know where we're beginning. For a new building, that baseline might be the energy code. And then we go from there and we look at peers that have similar climate, similar building type, and similar energy sources, and understand what peer buildings in that locale, how they perform. And then there are other tools that I'll say really stretch a project then. So the Zero tool is focused on that Architecture 2030 challenge. Energy Star Target Finder definitely has a threshold. You have to be in the top quartile of buildings of your type in your climate in order to be eligible for Energy Star. And then the laboratory benchmarking tool is being used as well in that kind of sphere to understand, how are we comparing to our peers, but then also stretching performance. An owner's own portfolio might also give some insight to, what have they been willing to buy in the past, if you will. And so that is also a good starting point. All right, so now let's talk a little bit about, as we get into conceptual design and schematic design, what occurs with the energy model. So before delving deep into design details, we use energy models to run basic simulations that can guide the project's overall direction. So this would be something called like a simple box energy model, if you're familiar with that term. Making energy efficient choices at this stage can set a strong foundation and prevent costly changes down the line. Energy performance goals can inspire unique and innovative design solutions that may not have been considered without modeling insights. Ideally, we'd like to see projects lead the schematic design phase with a clear roadmap that articulates high-level design strategies and, more importantly, communicates to each design team member what their role is in making this energy performance goal achievable. So we talked a little bit, we're going to kind of dive into this example now a bit, but once we have our energy goal, we need to figure out a way to achieve it, right? We can talk about goals all day long, but if we don't have a plan to get there, that goal is kind of useless. So we try to establish an energy roadmap when we're early in design. The path to your energy goal can be developed using that simple box model and provide strategies and options, but it also can be married up with technical feasibility to reach the goal. So while also considering the design intent outlined in the OPR. Some other questions to consider are listed here on the left side. Let's talk a little bit about this example project that I have here on the right side of the screen. So as a part of a pre-project planning, so that's an important element. Pre-project planning in this particular circumstance was the client actually engaged us to do an energy model to understand the feasibility of getting to net zero before they even released an RFP for design services. So they wanted to understand feasibility of their goal before they put anything into an RFP for an architecture and design team to respond to. So through that effort, we developed 9 cost-effective energy conservation and renewable energy measure bundles to achieve the net zero goal for a 13-story, 370,000 square foot office in Atlanta, Georgia. We had a partner on this project that helped us with photovoltaic assessments. I always get tongue-tied on that word. And we established an energy utilization index target based on probable site-based renewable energy availability and evaluated the site-constrained massing strategies. So we had a very, very specific site that we were looking at. The building really could only be a couple different directions. And based on the size of the project, there were really only a few massing strategies that would work. So after we identified the optimal massing and orientation, we then analyzed 60 different energy conservation strategies that ranged from envelope improvements to mechanical system types to changes in the lighting system. And we started to bundle them together and we performed life cycle cost analysis to identify the most cost-effective solution. So this table here at the top of the screen shows the performance of the 9 bundles. Bundle 7, which is highlighted, was the most cost-effective and demonstrated a 7.5-year payback. It definitely was the clear winner for this project. On this graph, this is how we communicate some of our energy performance results. So on the graph here on the left, and I hope you can see my cursor. On the left of the graph, you see that the baseline, how the baseline ASHRAE 90.1 2019 performs. Each of these colors indicates a different end use. So lighting generally is yellow, space heating is orange, space cooling and all of the associated equipment is in blues. And then we get into this miscellaneous equipment, which would be all of our internal like plug loads and process loads that we would be expecting. The green bars then, this is all for bundle 7. So this is the bundle 7 performance. The green bars are how the different ECMs showed up and contributed to this ultimate performance of a 65% reduction. So our energy efficient envelope really got us a big chunk of the way there. And then we layered in lighting systems and controls. And then after those 2 big chunks were done, there wasn't actually much more we could do to the mechanical system because everything from an internal load standpoint had really been optimized. All right, so this bundle offered a 7.5-year payback. It included a variety of conservation strategies, including optimized wall performance, electrochromic glass, so the glass that changes solar heat gain coefficient depending on daylight availability. It also included demand control ventilation, airside energy recovery, magnetic bearing chillers, condensing boilers. So this was not an all electric building. There was natural gas use on site. And then there was an extensive effort to harvest a lot of daylight, but then marry that up with an ultra low overhead lighting power density that was coupled with individual task lighting at desks. There was a parking lot component that also had an ultra low lighting power density and occupancy types of controls for the parking deck. And then one of the interesting things about this one was this jurisdiction allows no domestic hot water systems. So it does not require, I should say, this domestic hot water for hand washing purposes. And so in this particular design, one of the strategies was to not install a hot water, domestic hot water system for hand washing. But from an architectural standpoint, we also had active stairs, and to credit for reducing the amount of elevator energy consumption that would be associated with a 13-story tower. So active stairs is an interesting strategy, especially if something's more of a low rise. Ultimately, this bundle demonstrated an EUI of around 20, which for an office building in Atlanta, Georgia, is a significant improvement over what those normally consume, which is probably more around an EUI of 50. Okay, so moving on now, let's talk a little bit more about early phase models and how they play a crucial role in developing our roadmap. So this slide really is intended, the next couple are intended to give you kind of an idea of how you might use an energy model for those early things. So one of the things that we look at often is building orientation. So really this comes into play when the site is, does not have significant constraints, and that we can, site a project or a building in a variety of ways. So designers can get preliminary insights into how orientation affects energy consumption. We also look at how daylighting opportunities are affected by orientation, and then also a little bit of thermal comfort comes into play there as well. All right. Here we also look at envelope design. So early phase models, usually in our experience, have a focus on optimizing our envelope performance. Designers can obtain preliminary insights into how the that's my orientation notes, not my envelope design notes. We would be looking at maximizing, how much insulation would be able to be included, considering budget and some condensation factors, but then also looking at, what is the appropriate amount of glass. That ultimately is always a question on every project. And what type of performance does that glass need to have? Let's see. For HVAC system selection, we look at, I would say high level, what types of HVAC systems would be appropriate for this particular project. For a school project, sometimes we compare ground source heat pumps with traditional VAV overhead with maybe a third system type. So really kind of looking high level of what system's going to be putting us in a better position to achieve our energy goal than maybe other systems. And then marrying that up with life cycle cost analysis as well. All right, so we're back to this kind of workflow or integrated process graph. And so one of the things that that we often will do with energy models is carry it forward. So we've already defined our roadmap. Now we need to carry it forward to make sure that the design is moving in alignment with that roadmap. And then when hurdles are met, ultimately we can leave schematic design with a roadmap that might not end up being technically feasible later on because information that we did not know during that early phase comes to light. So really at design development, construction phases, we're looking at using the energy model as a guidepost, as a review process, a third set of eyes, if you will, to understand, okay, is the design tracking along that roadmap? Are we on track, or do we need to make some adjustments? Or do we have new information that makes one of our strategies inappropriate. And then working to evaluate new strategies to make up for what has been lost. Then during the post-occupancy phase, this is really about monitoring and validating performance. So once the building's occupied, actual energy consumption data can be compared to a model's prediction to validate both the model's accuracy, but then also inform whether the building is operating as expected. So we have found a myriad of things during post-occupancy or post-operation that have the energy model has actually helped identify things that have been going wrong. So this can be married up with some commissioning activities. And, for example, we were working on a project at Colorado State University. And when we were receiving some of the post-occupancy data, we were seeing that one of their pumps was operating at a constant speed and a constant volume all of the time. And it really should not have been. And we found out through collaborating with the commissioning agent that the pump had been installed incorrectly and the controls were not set up accurately. So it was just one kind of insight of like, well, okay, we expected this pump to be performing in this way. We're seeing it perform something else, another way, and working with the owner to get it corrected. But without that energy model, that may not have gone, that may have been overlooked for a long period of time. Okay. All right. So, so all of the energy modeling things that we talked about so far has kind of a backdrop of ASHRAE 209. So ASHRAE Standard 209 was just recently updated in October, but it's the energy simulation aided design for building except low-rise residential buildings. I love ASHRAE and how long they make all the titles, but it provides guidelines and procedures for using energy modeling in the design and construction process. You can use ASHRAE 209 to create a comprehensive energy modeling scope of work. And we kind of think about that in three ways. And we've talked a little bit about this already. So identifying project goals, we select appropriate modeling cycles that kind of pair up with those modeling goals, those project goals. And then we outline project milestones. So, creating a timeline for energy modeling activities, highlighting key milestones in the design and construction process. And really specify when energy models should be delivered and reviewed by the project team so that they can actually be useful for the team to make decisions. So if you're struggling with writing some scope of work information, you could turn to ASHRAE 209 to provide some common language that would be understood throughout the industry. All right. So when we're talking about energy models, sometimes energy models are done by a design team members like an HVAC engineer or an architect, but sometimes you're going to engage with a professional energy modeler that maybe has the building energy modeling professional certificate from ASHRAE. So someone that's kind of dedicated to this. All energy models, regardless of where they fit in the design team, are technical experts. They become the energy translators on projects that bridge the gap between complex data and actionable insights. They contextualize data by putting technical results into the context of a project's goals, whether it's energy efficiency, cost savings, or sustainability certifications. For architects and designers, energy modelers translate energy performance metrics into design adjustments, such as envelope changes, HVAC system selections, or orientation refinements. But for building owners and decision makers, energy modelers provide high-level takeaways, such as financial paybacks, operational savings, or carbon footprint reductions to facilitate decision-making. So, so if you're not accustomed to hiring a dedicated energy modeler for your project and you're working on something fairly complex, I would definitely recommend, thinking about how that fits into your workflow to be able to harness that technical expertise and communication element that energy modelers are able to bring. All right, so with that, as I was developing the concept for this presentation, I realized that energy modeling can really only be effectively used on projects if design teams know how to interface with the modeler. So I created this checklist. If you use the QR code, it will just take you directly to the downloadable PDF. You don't have to enter any information or anything like that. And I will also include this checklist as a follow-up with the slide deck too. But this checklist is a comprehensive guide for effectively managing early phase energy modeling tasks. It ensures alignment, clarity, and efficiency in the initial stages of a project. Basically, it comes down to how are you going to talk to your energy modeler? So the checklist includes topics like project understanding. So starting with a clear understanding of a project scope, its goals, what constraints you're under. No, it gives a framework for providing essential data for the energy model. Clarifying expectations helps if you're working with an outside energy modeling group. It defines the scope so that that entity might not run into scope creep, which can be a problem with energy modeling work. But it also clarifies what types of deliverables you need, when you need them, and prevents misunderstandings. We go into, interactive, I'm sorry, my words are getting jumbled now. We're looking at collaboration. So fostering an ongoing collaboration between design team and energy modelers means that iterative feedback loops will be utilized to help refine the design and optimize energy performance. The checklist also covers things like how HVAC and different systems interface. So coordinating work between mechanical engineer and your energy modeler, so that that model represents the best available information at the time it's being created. And then goes into talking about understanding feedback, like how might you use energy modeling information. And then a really critical piece of energy modeling is documentation and record keeping. It's kind of the boring part of energy modeling, but maintaining thorough records of all modeling inputs and assumptions and the results and the decisions ensures that transparency is there for your project team. But then also being able to go back in time and say, why did we choose this thing here? Helps to unwind some of the value engineering activities that can happen that sometimes degrades project performance. Ultimately, there is an opportunity then to educate design teams and share insights so that future projects can benefit by the effort that was done on our project. All right, let's see. So I'm going to do a time check. I'm looking at, it looks like we are at 50 minutes. So Dylan, would you like me to continue through this next phase kind of at a rapid pace, and then we'll have some Q&A?
For us.
Sorry, what's that?
It works for us.
Okay, sounds good. All right, so I have a slide in here that talks a little bit about how much an owner should spend on an energy model. I don't have specific numbers here to share, but just some food for thought. So certainly, as projects grow in size or become more complex, they're going to cost more to model. If a local code is highly stringent and will require multiple rounds of ECM testing to get the building to comply, that also takes time. It takes both engineers' time as well as collaboration time to get that right. But then it's also about, what are the budget limitations on a project? And we'll talk a little bit about some ROIs here in the next couple of slides. But there are incentives available, and we'll talk about that here in a moment. There are a variety of ways that energy models pay for themselves. So you think about reduced operational cost savings. That's something that happens year over year as the building's in operation, especially if it's gone through a really stringent commissioning effort with measurement and verification. But then there are some things that are more upfront, like tax deductions and utility incentives. There are a variety of financing options available, and depending on what's available, like depending on where the project is, might dictate what's available for that project. There is a good website. It's and it'll be in the notes, but it's desireusa.org. You want to make sure you spell that right, but it's DSIREUSA.org. You can sort or search for financing and incentive options that are available in your state using that resource, and it's kept fairly up to date. All right. Of course, we've heard a lot about the Inflation Reduction Act investment. We're expecting to see 48 billion investment in the building industry, primarily through two things: the business energy investment tax credits and the energy efficient commercial building tax deduction. We're not going to cover the business investment tax credits today, as they don't really relate to energy modeling directly, but we can go through a little bit of the section 179D deduction. So the section 179D provides a tax deduction for energy efficient commercial building improvements that include all the systems that you see here on the left side of the screen. It uses an energy model to demonstrate that 25% regulated energy cost savings has been achieved. And if prevailing wage and apprenticeship requirements are met, so basically if you're using union labor on your project, you get to multiply these incentives by 5. So these incentives by 5. And there's a maximum deduction of $5 a square foot. All right, so for example, and it's a sliding scale. So for example, if your project demonstrates a 35% savings, and it either will be 70 cents a square foot, or with prevailing wage will be $3.50 a square foot of a tax deduction. All right, so how is this determined? Of course, because it's in this presentation, it's determined using an energy model. It's compared to ASHRAE 90.1 2007 as the baseline. But what's important here is that it's only regulated energy costs that we're actually looking at. So while plug and process loads are excluded from the savings equation, they're still included in the energy model as they affect how building systems operate and perform. But we get to extract the energy cost associated with those plug and process loads to determine the savings percentage. Since you guys have a local energy code that's IACC 2018, what we have found is that gives projects a benefit or an advantage. So the 90.1 2007 baseline, you can see on this graph, IACC 2018 kind of falls in this region. And that right now is about a 20% savings, depending on project type. So you're almost all the way there to that 25% threshold just by complying with local code. Now, if your firm is a signatory or you work with architecture firms that are a 2030 commitment signatory and they're meeting that, then those types of projects are likely eligible for the full 179D tax deduction. After 2026, the baseline does change. So I'll just kind of run through this. Changes to 2019. And so in that case, projects that are achieving that 2030 commitment target would be what's eligible. We've developed this kind of litmus test, very simple 4-question test to determine whether projects have a high likelihood of achieving the deduction. If you can answer yes to these questions, then your project is likely eligible. And then if it goes in service after 2026, it would have to answer yes to these questions to be eligible. All right, I'm sorry that I'm not providing much time for questions, but I do want to kind of run through kind of the math on one of these projects so you can understand, you know, kind of the ROI of energy modeling services. So this project is in Milwaukee, Wisconsin. It's a high rise, 600,000 square feet. We showed through the energy model that it had about $130,000 of annual energy savings compared to the local code, IUCC 2021. It qualified for almost $2.2 million of tax deduction. And when we convert that to cash value, assuming a 21% marginal tax rate, that's about $470,000 of cash value for a year one savings of $600,000. Compared to the energy modeling fee, that's a 400% return on investment and starts to become a really pretty compelling case for business owners. So we had a similar project here, and then I'll leave the conclusion slide up for our Q&A. So that's it. I'm sorry for the race at the end. But I'm happy to stay on if you have questions. Otherwise, I understand if you need to cut the meeting off.
Questions?
Okay, so Kara, it looks like you're asking, what does the energy model pull the costs from that are used in the first cost premium and energy cost savings for each option? How accurate are those costs? So first cost for sure would be done initial costs for equipment and things. That would be done in a traditional way of getting cost estimates from contractors or parties or estimators that are part of the project team. There is definitely a complicated workflow related to getting accurate information. But then the energy cost savings, so the energy performance, is really kind of dependent on your utility rates. So getting accurate utility rates into the energy model will help inform what that energy cost is. Does that help answer the question? Did I answer the question fully, Kara? Thank you. Awesome. Great question. Any others?
Any other questions online? Okay, thank you very much, Amanda. Appreciate the lecture.
All right, very good. I will follow up with you with a copy of the presentation and that checklist.
Thank you guys for coming. If you could please fill out the evaluation